So real quickly, just an announcement. Your third test is coming up next week. Yours will be Thursday in class. And what does that even mean? It means that on test day, not only are you preparing for your test, but any late work is due by the end of next week. We didn't have a quiz this unit, so you don't have any quiz retakes, but if you are still wanting to retake test 2, you can do that by next Friday. You won't have an option to retake test 3 before report cards, so try to do the best you can on it. All right, we're kind of gonna modify the notes a little bit, and I'm cutting out some of the harder problems in the notes and homework. So on your homework, some of the problems on the key, it will say omit 2020. So we're not doing those this year. On your notes right here, I've omitted step 3. It was for the harder problems. But I do want you to take a few minutes and write down these steps. If you are working asynchronously, please pause the video right now and write down these steps if you don't have them already printed out on paper. All right, so let's put those steps into action. This is our first problem. Go ahead and take a second and write that down. It is the cube root of 6x minus 7 over 4 minus 5 on the outside equals negative 6. Step 1 said to isolate the radical term. Oh, and I'm so sorry. I should have told you could cut out this part for 2020 as well. I mean, it's too late if you already wrote it down, but for that first step that says if it has 2 radical terms. I'm so sorry. You didn't have to write that down. I apologize. You could have used that information like 5 minutes ago. So back to the problem. The first step is to isolate the radical. So let's figure out what I'm talking about before we can make a plan on how to isolate it. So it's just this piece, the piece that has the cube root in it. Right now it's being divided by 4 and subtracting 5. Now let me give you sort of a simpler problem. Let's say instead of that radical I had just x. I'm just going to write some notes over here. If I had just x by itself over 4 minus 5 equals negative 6. So everything the same, except there's no radical. If I told you we're trying to isolate x, what would you do first in that smaller equation? Would you take care of the negative 5 first or the 4? You could do the 4. You would have to multiply, right? And then you would also, though, have to multiply that negative 5 over by adding it. So you would add 5 and then multiply by 4 to get the x by itself. And so that's what we're going to do in the actual problem to get the radical by itself. So step 1, isolate your radical term. I'm going to add 5 to both sides. Which gives me cube root 6x minus 7 over 4 equals negative 1. And the radical is still not by itself. It has a divide by 4 on the outside. So to undo that, I multiply both sides by 4. And on the right, that gives me negative 4. And on the left, it gives me cube root of 6x minus 7. And your step 2 said, apply the power needed to cancel the radical. So I have a cube root What power would I need to cancel that out? What undoes a cube root? Power of 3, right? So just like squaring a square root cancels it out, cubing a cube root cancels it out. But you have to do it to both sides. And so that's your step 2. So what that leaves you with on the left is just 6x minus 7. So the power of 3 cancels out the root of 3. And on the right, remember that negative 4 cubed means negative 4 times itself 3 times. So the first two negative 4s give me positive 16. And then times the third negative 4 is negative 64. And now we just have this baby equation. You solve your baby equation, I'm going to solve mine. It's not a competition. Where is it? Also, you always want to try and simplify a fraction if you can. And this one can. 3 can divide out of both of those numbers. And just a little mental math trick. For 57, 5 plus 7 is 12. 12 is divisible by 3. Therefore, 57 is divisible by 3. And that works with any number. If it can add up to something that can be divided by 3, the actual number can as well. So x equals negative 19 over 2. So step 3 doesn't apply on any of our problems today. So that was step 4, solving. And step 5, again, is a non-negotiable. It's not just like, go check it for funsies and see if you got the right answer or not. What we have to check for is if this is an extraneous solution or not. But actually, we don't have to check on this problem, and I'll tell you why. Look at what you wrote down for step 5. It says, let me show it to you. Oh, dang it. I didn't write it down. I'm just messing up the whole thing. I want you to add this to your step 5. Check for extraneous roots when, so by the by, I'm modifying the step 5 that you wrote down. So if you want to add that, this is what we're adding. Check for extraneous roots when applying an even power in step 2. It's because I was modifying how I wanted to teach us like literally 5 minutes before class started today. So that's why I'm kind of, it's all messy and weird. Check for extraneous roots when applying an even power in step 2. So if I go back and look at the problem we just did, when we applied a power to both sides, the power was 3. Is 3 even or odd? Nobody wants to answer. I know you all know. 3 is odd. So we do not have to check for an extraneous root. So here's what I want you to actually write down somewhere on your notes for this problem. Don't have to check for extraneous when power is odd. Don't have to check for extraneous solutions when the power is odd. So we actually can just stop here. X equals negative 19. Does anybody need the screen up anymore? All right. We just have one more problem to do. If you had your notes printed out, or you looked at or you're looking at them on your computer or phone or something, we're not doing the third example. We're omitting it for 2020. So this is going to be our last problem for today. It's square root of 2x plus 31 plus x equals 2. And we start out the same way. Step 1 is isolating the radical. So let's be sure we know where that is. It's just this piece right here. But it's not isolated yet, meaning it's not alone. It has a plus x on the outside. So we need to undo that plus x by doing the opposite. So now I have square root 2x plus 31 equals 2 minus x. And step 2 is raise it to whatever power you need to get rid of the radical. What power do I need to get rid of this radical? 2, perfect. This is a square root. You know it's, when no number is written, you know it's understood to be 2, a square root. And so to undo a square root, you raise it to the second power, and you have to do that to both sides of your equation. And so what happens on the left is the power cancels out the root, leaving you just what's inside. The stuff inside is called the radicand. Not the radicand. And then on the right-hand side, what this means, 2 minus x parentheses squared, it means 2 minus x times itself. And that needs to be FOILed. So you FOIL your right-hand side, I'm going to FOIL mine quietly, and then we'll come back together. So you're foiling your right-hand side. And so you should have 2x plus 31 equals 4 minus 4x plus x squared. Step 3 does not apply because we don't have any radicals left. So what we have to do is factor and solve. Now, here's how we know we're going to have to factor, because there's an x squared on the right-hand side. So whenever you see an x squared, so you see x squared, you think factor, and when you think factor, then you think set equal to 0. And usually we will get it 0 on the right, but I'm not going to do that here. Because look at my x squared, how it is right now. It's already positive. I want it to stay positive. So I'm going to keep it there. So in order to get it 0 on the other side, I'm going to move 2x plus 31 over by doing the opposite to both sides. And when I write it over here, I'm going to line it up under the like terms. And I'm going to write it in standard form. So what I want you to do now for the next couple of minutes is factor and solve that expression. And we have to check for extraneous, because when we raised it to a power in step 2, the power was even. It was the power of 2. That's an even number. So you're going to factor, solve, substitute into the original problem to make sure it works in the original problem. If it doesn't work out, you're going to call it extraneous. What's to factor, starting with the cross thing. So what multiplies to negative 27 and adds to negative 6 is negative 9 and 3. The a value is 1, and dividing by that doesn't change anything. So my factors are x minus 9 and x plus 3. And you set each of those equal to 0 and solve them. And that gives you positive 9 on the first one and negative 3 on the second one. And that was step 4, solving your equation. And step 5 is where you check for extraneous solutions. And we have to in this problem because the power in step 2, when we raised it to the second power, 2 is even. And in that circumstance, we sometimes get extraneous solutions. So we have to check. Now, when you check, you use the original problem. So here was the original. Square root 2x plus 31 plus x equals 2. Now I'm going to plug in 9 for the x's and check it out. So here's me checking out x equals 9. I have square root of 18 plus 31 plus 9 equals 2. I got the 18 right because I did 2 times 9. And then that's square root of 49 plus 9 equals 2. And when you take the square root of 49 here, it's just 7. The reason why it's not plus or minus 7 is because we are not introducing a square root into the equation. The square root was already there. When the square root is already there, you just need the positive version of it. It's what's called the principal square root. So it's just 7 plus 9 equals 2, which is not true, right? It is not true that 7 plus 9 equals 2. So we know that x equals 9 is actually extraneous. And then we need to check x equals negative 3. So in the radical, when I plug in negative 3 for the x, I get 2 times negative 3, which is negative 6. And then minus 3 equals 2. And that gives me radical 25 minus 3 equals 2. And square root of 25 is 5. And it's true that 5 minus 3 equals 2. So that solution works. So our final answer is x equals negative 3, x equals 9 is extraneous. And your grade for today is to just post a picture of these notes in your Google Classroom. So we are done. If you're in